Hi all, welcome you all to this new video today. So this is Michael Jones, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. So welcome to this video on production technology. So again, we are going to continue the topic metal forming and powder metallurgy. So in metal forming, today we are going to see on forging. What is forging? So principle, the application of forging. What is metal forming? So the metal forming encompasses manufacturing process that reshapes the materials through plastic deformation without removing the material or changing its composition. So that is metal forming. We are going to change the shape or dimension of the object. The key bulk deformation processes extrusion, rolling, drawing, and forging. These are four different types of metal forming processes. So extrusion is done through forcing through dies. Rolling is done through reducing the thickness. Drawing is pulling through the dies, and forging is compressive shaping. So forging stands out as the most versatile process for creating high strength components. So forging through ages. How and what is the evolution of forging process? So in ancient origin, blacksmiths, then through industrial revolution, steam powered hammers were used, and now in modern industry we are going to use hydraulic presses for precision forging components. So the modern forging techniques was aged 4,000 years ago, and forging is an ancient practice that has been in life. Then the core principles of forging. So the core principles is compressive forces and essential tooling. Compressive forces is that we are going to have plastic deformation on the material through material integrity. And essential tooling is that we are going to use hammers or presses or dies, special manufactured dies that can be used, engineered dies can be used for forging. And unlike extrusion process, here also forging also we are having hot forging and cold forging. So hot forging is done at elevated temperatures and cold forging is done at room temperature. And what are the types of forging that is used? So open die forging, closed die forging, that is very commonly seen. So in open die forging, the metal flows freely from flat dies. And in closed die, the metal is confined into the regular shape of the die. What is the very vast advantage or disadvantage through open die forging and closed die forging is that when in open die forging the material is allowed to extrude, it is allowed to expand. But in closed die forging, the metal is, though it is a compressive process, though forging is always a compressive process, in closed die forging, the metal is made to be confined into the shape. So all the internal grains will be very closely compact. It will be having very high and superior strength. So that is the larger difference between open die forging and closed die forging. Then in precision forging is that we will be using a near net shape process requiring minimal machining and tight tolerances will be used. In upset forging, it increases cross-sectional area by compressing the length. So the length will be compressed, and the commons for bolt, valve stems, and electrical contacts will be used through upset forging. Then forging equipment and machinery. So what is forging equipment and machinery is that what are the tools that will be used? So already we saw hammers, drop hammers, hydraulic presses, and mechanical presses. Hydraulic presses done through the hydraulic energy, and mechanical presses done through manual mechanical energy. Die sets. Dies is that the tools that will be used to make the shape. And what may be the industrial applications where all the forging can be used? So in automotive industry, aerospace industry, and tool manufacturing industries. So I've just taken a very smaller sector, a very little example here. So in automotives, what are the components that will be done through forging process? So in crankshaft, the connecting rods inside the engine, the crankshafts and the connecting rods will be done through forging. Transmission gears and steering components will be done through forging. Because why are these components made through forging processes? That these components will be experiencing shear force, and it will be experiencing a combined loads over the components. So during that, all the machining, manufacturing application components will be of no use. So only forged components will be used. In aerospace sector, turbine blades. So turbine blades will be experiencing very large temperatures. So those temperature shifts will be managed through forged components. Tool manufacturing, spanners, hammers, wrenches, all these equipments will be used through forging components. Then the key advantage is superior strength, enhanced reliability, and economic efficiency. Also, already we saw superior strength, the grain flow alignment will be done. Then enhanced reliability is that elimination of internal voids and defects through closed forging. Will be having a very compacted structure. Then economic efficiency, the per unit cost will be very low because we'll be reducing the metal scraps. The limitations is a high investment already saw, geometric constraints and production volume requirements. We cannot use forging for very little number of components. So when the volume increases, then the production rate will be reduced. Forging is the key takeaways for this presentation. So forging transforms metal through controlled compressive forces. Multiple process variants suit different applications. Superior mechanical properties justified widespread adoption and critical for automotive, aerospace and tooling industries. So this is a little topic on the forging complex. Thank you.